Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're going to be taking a look at the Apple II and specifically an open source card that plugs into this machine and gives you pixel perfect VGA output, which you see right here, and also can emulate or replicate one of these PCPI Applicards, which is a pretty rare and expensive CP/M accelerator card for the Apple II. And it's all possible with something that's open source hardware and software. So without further ado, let's get right to it. This Apple IIe Platinum is currently configured with the card. It's in slot 5 here, but it can actually work in pretty much any slot except 3 is not an ideal slot, but any of the other ones will work. And there it is, pixel perfect VGA output. And it completely is working properly. As you can see, Control-Delete, Open Apple Control Reset gets us into the basic prompt there, and it's working really, really well. I've had this card for a couple months so I could play around with it and discover the compatibility issues that may exist or any bugs that may exist. And I found a few, but the creator of this project or the maintainer of this project has been really responsive and added features and other capabilities to it that weren't even there right from the start. Now, as you can see, it's quite a simple card, and it's using a Raspberry Pi Pico as the brains of the operation, which is a nice change from using a regular Raspberry Pi that runs Linux, because all of those are basically impossible to get. But this one, on the other hand, well, it's easy to get and it's very inexpensive. And it's fully open source as well, which just makes this project that much better. All the heavy lifting is done by the Pi Pico, and there are just some level shifters and some other logic chips on here to handle the bus on the Apple II. And then there's a VGA connector right there, but it's really, really simple. And what's really cool about this project is because the Pico is doing all the heavy lifting, it's possible this card can become many different things. As I mentioned in the intro, it is currently able to become one of these Applicards here, which runs CP/M at a pretty fast rate on the Apple II, and it really absolutely works perfectly. This can become this. And that is all made possible because the Pi Pico, well, it's got some horsepower to it, and I think with overclocking, it has quite a lot of capabilities. Because the Pico is connected directly to the bus through these transceivers, well, the Pico could emulate pretty much anything. How about a mouse interface? Or how about a serial port? Or a parallel port? Or even a disk interface? Anything is potentially possible with the right software. What really does excite me about this project, though, is the fact that it's open source. That just means that the community can contribute to this and enhance the capability. It's not just one person working on this project and that's all it's ever going to be, especially if that person runs out of time and can't devote any additional time to add functionality. Now, when it comes to VGA adapters for the Apple II, there are alternatives out there. I don't actually have any of them personally, although I have the RGB to HDMI, which is possible to be used with an Apple IIe or II Plus, also a 2C, but it's an external device, and as I mentioned, it requires a regular Raspberry Pi, which are impossible to get right now, so it's not really an ideal solution anymore. I know at least one of the other VGA adapters for the Apple II has an HDMI output on it, but it uses something like a Raspberry Pi, but I think it's like an Orange Pi or something like that, and it sits on a card just like this and monitors the bus signals and is able to output the video. But it's not an open source project, so you're at the whim of the developers, and not to mention the cost of the device, because you can't just have one made yourself. Now, if you're familiar with the Apple II, you might be wondering how a card just like this could plug into any of the slots in the motherboard and then just output an actual video signal. How is that even possible? Well, the way this project does it, and I think the other VGA card adapters that plug into the slots on the Apple II work, is that they literally monitor all bus activity that is passing through the data bus and the address bus, and they reconstruct the video memory and all the commands that go into drawing the video signal inside a buffer inside the, well, in this case, in this Raspberry Pi Pico. The Raspberry Pi Pico here is not emulating an entire Apple II, but what it does emulate is the entire video subsystem. So any writes to the soft switches on the Apple II, which might say turn on high-res mode, will activate the high-res mode inside the Pico as well, and then say you write to video memory to display a letter or a line on the high-res screen, well, the same thing is going to happen inside the frame buffer here. One thing that's kind of interesting about that is that if the main memory in the computer, now this machine has just these 2 chips down here for RAM, but if you had an Apple II Plus with some bad memory in the range that was used, say for the high-res screen, on the actual composite output for the computer, you might see some garbage or problems there. But this thing wouldn't actually show a problem because it's reconstructing the image inside its own memory and it's not reliant on the memory on the motherboard. Faulty chips on the motherboard won't have an effect on the video that's displayed on this. Of course, if you have a faulty RAM chip, it might cause the computer to crash, and then you're going to see the crash on this device as well. But it's pretty intriguing the way this actually works, and it opens up extra opportunities, which David, the maintainer of this project, is already working on, and that is adding AppleII-VGA graphics mode support to this. I don't have that firmware yet, but he sent me some screenshots of this able to display these higher resolution modes on the 2GS doing the exact same thing, just monitoring the activity on the bus. Let's take a look at this in operation. I'm just going to stick this into slot 5. As I mentioned, it doesn't really matter what slot you stick it in. I don't think it would work in slot 0 on an Apple II or II Plus, but it works on any of these other slots. The only reason why you wouldn't want to use it on slot 3 on an Apple IIe is because the slot 3 I/O is already mapped to the internal 80 column card that this computer has on the motherboard. So you can't actually control or talk to this card. It's still going to work, it's going to display VGA, but it's not actually going to be able to be manipulated, the settings that are on it. For plugging in a VGA cable, I think normally on an Apple IIe you can take off one of these back plates here and you can feed this cable right through it. On an Apple II Plus it's even easier because you can just lay it right through the openings that are in the case. And incidentally, I did test this card on an actual original Apple II, not even an Apple II Plus, and it works absolutely perfectly on that as well. I haven't tested it on an AppleII-VGA, but David tells me that it does work on there without any issues. What you're seeing right here is the test pattern from the open source scan converter because I haven't yet turned on the Apple IIe. Let's turn this on and we should see an image here once my capture device synchronizes to the signal. There it is. I booted up the game Droll. That is the crack screen on it, or Cracktro screen. Loading the game here. It should come up in a split second. That's just normal Apple II speeds. There it is, and it's looking fantastic. Now, originally David was using artifact color decoding that I thought could use a little bit of an improvement, so that was one of the things I work with him on, and he improved it, and I think it looks pretty great. Look at the Broderbund logo there and the columns. That white there is great. It doesn't have any fringing. Overall, the whole thing just looks fantastic. Now what you're looking at here is the composite video output from the Apple IIe connected to the RetroTink, and it looks pretty similar, but you're going to be seeing more color fringing around the text, the logo there, and the columns have a little bit of a purple look that we don't get on the VGA output. That is really one of the differences you get between looking at composite, even though it's converted to HDMI, compared to the RGB color, which has a much sharper pixel perfect look, and I accidentally started the game here. That's what's going on here. It's not going to be exactly the same as what you have on composite with that color fringing. So if that's what you're looking for when you're using your Apple II, you should probably rely on something like a RetroTink or some external solution to convert the composite video into something modern that you can use with a modern display. In the case of this though, you're going to get really, really sharp text and graphics. There's some text, and as you notice, it's looking really, really sharp. Now, when you have the output connected to a VGA CRT or an LCD, it's really going to look pixel perfect. On the open source scan converter, there's a lot of settings for sampling. If I don't have those exactly right, you might see a little bit of scaling artifacts, and that is coming from the open source scan converter, and that is not coming from the VGA board that's in this machine. Any softness you might notice around the characters here on this captured video is also not visible when you have it hooked up to an LCD panel. It absolutely is pixel perfect. Now here's an example of something where these VGA cards absolutely shine through. So I'm running the diagnostic on the IIe, and you can see that there's low res color up at the top, but at the bottom there's text, and there's no color fringing on that at all. If we switch over to the composite video through the RetroTink, well, you're going to see there what you would see looking at that text through a composite monitor, for instance, lots of green and purple fringing around that text, and that's just because of the way the Apple II color works. This machine, unlike something like a Commodore 64 or an Atari 8-bit machine, uses artifact color to generate all of its colors, which means anytime there are vertical lines that are single pixel wide, like on the fonts, well, when you have the color mode enabled, which of course it needs to be if you're showing color on the top part of the screen, then you're going to get that purple and those green lines on the text. But here it has jumped back to text mode only, even though we're through composite, and you see there's no more color fringing, and that's because the Apple II disabled the color burst on the output, which on composite monitors, but also the RetroTink, it disables the color decoding altogether, which gets rid of that fringing. There are a lot of compromises to the way the Apple II video works, and we're going to show you an example of that here. So I'm loading up the game Archon from Electronic Arts. And one of the problems with this game is that the fonts there, you can see, are single pixel wide, and it makes them a little bit hard to read because of all that green and purple. And this is the RGB or the VGA output coming out of David's card. Now here we've switched over to the composite video that is through the RetroTink, and you'll notice it's really got the same things going on. There's a lot of fringing around the text. But on this screen, there is less fringing when we're looking at it, of course, through the RetroTink, and that's because the fonts are using double pixels, which helps minimize the fringe. You can still see the fringe there, but moving back to VGA, it looks much better. Here you see the game actually working though. We're looking at the VGA output and it looks really good. Notice around those white boxes, no fringing or anything. It's looking absolutely fantastic. This is Fat City, one of the games I always like to demo, and look at it on VGA looking absolutely fantastic. Bright, vibrant colors, really, really sharp. Pretty much awesome actually, I have to say. And again, on this screen, notice at the bottom it says cracked by Mr. Crackman. Nice sharp text with no color fringing. Really, really good. Now here we are on basic, and this of course supports 80 column mode on the Apple IIe and on the Apple II-GS as well. I don't know actually if it supports 80 column mode on, say, an Apple II Plus, if you had like a VidX card in there, but at least on the IIc and the IIe, that works perfectly. And here we are, really, really sharp text with no issues. And of course, if we go into a graphical mode, even though there's no graphics on the top, know that the color is turned on right now, but of course the text is absolutely perfectly sharp. Back on composite, the text is, well, it's kind of fuzzy because the RetroTink, it has a little bit of filtering going on, but there it is. But if we go to GR color mode, notice that color fringing. It's really not so great, but that's just the way it is. 80 column text does not really work over composite video if you have color turned on and you're using a color monitor. Of course, if you have a monochrome monitor, like the little Apple monochrome monitors, will work perfectly. It doesn't matter whether the graphics are turned on or not. But when there is a color monitor used, the 80 column text that's at the bottom, those 4 lines, is always going to look absolutely terrible. And that is not going to be a problem when you're looking at it over RGB. Now, over the last couple of months, I've been working with David to try to fix some bugs, and there's still a couple in here, and one of them is if I hit Control Reset to exit out of 80 column mode, notice it's sort of stuck in 80 column mode. Now, this is happening on the actual card itself. It's not happening on the actual Apple II. If I switch back to composite mode, we will see the machine here is actually in 40 column mode as it should be. But on the VGA card, it is still in 80 column mode. Now, these types of bugs are completely a software issue and can be fixed with a little bit of a code update. When you do a soft reset on an Apple II, the processor jumps to a specific point in the ROM and starts doing some code there to kind of reset the computer, and that turns off the 80 column, it turns off the graphics modes, things like that. So Dave was actually able to see that operation happening in the card there, and he just hasn't finished writing that routine to disable the 80 column text and jump to 40 column. But that is a bug that he's working on and he will fix. Now, even with this bug, if you reboot the computer and you go into ProDOS, there it is. It actually drops out 80 columns mode, and that's just because of the way the ProDOS reinitializes the system, so everything looks like it's working okay. So there's actually a configuration utility that David wrote to control some of the parameters on this card. So I'm just going to enter into that now. I am using my floppy emu here instead of using a disk drive. The first thing the utility does ask you what slot it's in. In this case, it's in slot 5, and there it is. It's talking to the card now. The reason why that matters is because depending on what slot it is, the I/O addresses are different for each of the slots on the Apple II, so you just need to tell it which slot it's in. If we go to number 1 for card options, there are 2 modes this can work in right now, and it's VGA card mode, which it's in right now, and also the PCPI Applicard mode. And that is this card right here that I was talking about. This is an Applecard, a real one. It's a pretty expensive card. It's not cheap to buy these days because they didn't sell that many of them. Before I switch this card over to run as a Z80 card, let's just look at the other options really quick. We'll go back to the main menu. So there is a machine type, and you can have 2GS, auto detect, or Apple II or II Plus. Of course, IIe, which is what I'm using here. The biggest difference between the II Plus and the II and the other machines is they don't support lowercase text. So when you switch this into II Plus mode, the video subsystem works much more like the subsystem does on the II or II Plus without that lowercase support. There are a few funny things that you can do though, and you can use an Apple II Plus and set it for Apple IIe mode. And then what happens is when you run Apple IIe software that doesn't need the extra memory and it tries to use mouse text, which are like the graphical symbols that the IIe and the IIc have, or you try to use lowercase text, actually works, and it will display it through the VGA output. Even though on the composite video of the Apple II Plus, it's not showing the mouse text, but because this card is recreating the entire frame buffer and all that video processing in the card itself, well, it doesn't necessarily care that the real host computer doesn't support mouse text or doesn't support lowercase. This card is just gonna show it. You'll notice there's an auto detect option here, which is the default that the card goes to when you first flash the firmware onto it. And unfortunately, that mode doesn't seem to be working properly. It always thinks that the Apple IIe here is a 2 Plus. And I think what David's doing is watching for a couple writes to specific memory locations, or maybe it's the banner that pops up at the top of the screen. But for whatever reason, that's not working, but I'm sure that's something that can also be fixed. Now back at the main menu here, you notice there's like lots of space for other options. And I was looking inside the source code for it, and it seems like there's some stuff in there for like serial ports and things that, well, this card doesn't yet support. So he just hid those options, but just know that there are plans to add more capabilities to this card. The last options are somewhat self-explanatory. Format card just formats the storage on the Raspberry Pi Pico, which basically just factory defaults the card. So let's switch this thing into Applicard mode. Now, one of the negatives is right now is it cannot run as a VGA card and the Z80 CPU card at the same time. I think it might be possible in the future, but currently as it sits, as soon as you activate the Applicard mode, you lose the VGA output. It just stops working altogether. I'm going to use the floppy emu here to load the Applicard boot disk. And if I put the actual Applecard in this system while using the VGA card, but the VGA card were just set to VGA mode, and I put this in, well then we would see the actual Applecard interface come up on the screen. But in this case, I'm gonna leave that card out and we're gonna go to card options. We're gonna change it to 2. We're gonna go back to the main menu and we're gonna hit save and exit, and it's gonna say save, and we're gonna lose the video as soon as that happens. So I've just switched over to composite video before I hit yes for save. And I think what happens now is it does disable the VGA output, it's saving the configuration, and now the system is rebooting. And it's booting off the disk here. And I think we should end up, yep, load drivers, this is what happens. We're looking at over composite, and there it is. We are now running in CPM as the Applecard. I've done some testing in this CPM environment, and it seems to work exactly as well as the real card. I think David said that sometimes things can crash, and he's still tweaking some of the software to work just right, but I haven't actually encountered any issues with this particular firmware that he sent me. And in case you're wondering, yes, you could just run one of these cards in this slot and have another one in the slot next to it and have one of them be in VGA mode and one of them be in Applecard mode if you want to save money, not having to buy a real Applecard here, but you still want to retain the VGA output. Now this is where we encounter another bug with this card, at least at this point. If I reboot the system and I'm currently selected the configuration utility for the VGA card, when we boot back into this, it's no longer going to be able to communicate with the card. So let's run the config utility here, and when I hit slot 5 for where it is in the machine, it's not going to be able to talk to it. And that's a bit of a problem because it just times out with the communication, which means I can't switch it back to VGA mode. David's going to be working on the software to fix this particular issue, but currently you have to do a little bit of a workaround. Going to the machine language monitor and writing these bytes out to the card should do a factory default on it. So I've switched over to the VGA output, and when I hit enter, it should come back with the, well, the default sort of screen, and there it is. Yeah, this is what it looks like when you first power up the thing before it detects any bus activity on the Apple II. It needs some bus activity to start generating or reconstructing the video screen that it has in its internal memory. As soon as I hit control reset, it should then detect bus activity, and there it is. It has dropped us in. Now, what this has done is format the entire card, which means it's back in the auto detect mode, which is why it has a flashing cursor as opposed to the normal hash check pattern, whatever it is, on the Apple IIe, because the Apple II Plus does not support that particular character. In fact, if I try to type lowercase, notice it's giving us random characters as opposed to letters, and that again is because that lowercase font is just not there. If we reboot the system here, notice it's looking a little funky, and that's again the lowercase problem, but not an issue. There are 2 versions of the config utility here, E for lowercase on the Apple IIe and 2GS, I guess, and the regular config utility, which is all in uppercase. That's the one we're going to use. And we're going to hit 5 for slot 5. Notice it didn't give us a timeout error, and we're going to hit machine options, and we're going to change this to Apple IIe. We're going to hit there, and we're going to save. Yes. And now it's going to reboot the card, and I think the computer rebooted it as well, but there it is, it says no activity. We'll hit Control-Delete, or Control-Delete, open Apple Control Reset. There's the lowercase text. It is now working properly. What I've seen of this card so far has been really impressive to me, especially the fact that it can perfectly replicate the PCPI Applicard, which is just something that's kind of unexpected for a card like this. But when it comes to the video output, there is an issue that it has that I wanted David to address, and he actually did, although it's not fully baked into the config utility, which is why you didn't see an option for it. Let me demonstrate something. If I reboot the computer here, I've swapped the disk over to the piece of software called Music Construction Set. And here it is. It's a pretty amazing piece of software that allows the Apple II to play back multiple different notes through the internal beep speaker. One of the issues with this, though, is it uses single pixel wide, well, graphics assets, and that way you get quite a lot of this purple and green fringing on it. And I don't think that looks super great. This particular software just works better with a monochrome monitor or a monitor that you can at least disable the color. But on this VGA card, well, it's just not really possible. So that's one of the features that David went ahead and added. A monochrome mode. Right now, to control whether the monochrome mode is enabled or not, plus there's some other features he added, you got to do it through some, well, registers, which means poking some values. Eventually, I think it will be integrated into the control utility or the config utility, so you can just turn that off and on in there, and then just reboot the machine to access it directly. What I've gone ahead and done is write a little basic program to do this for me, because he just gave me a list of registers and it was quite a bit of a pain to poke them in every time. So I wrote this basic program. So I'm gonna hit slot 5 for this card being in slot 5. And here are the different options that it has now. So it has a 2GS color option mode. And what that means is when you turn on that mode, then the border color and the background and the text color are all configurable just like it is on the Apple II-GS. On the II-GS, you would go into the control panel to do that. Well, here you have to set, well, registers basically to do that, but it is there. So let's take a look at that first. So pick a text color. I don't know, I'm just gonna pick like a random number here and a random border color, 12. And there it is. We have really, really ugly colors that would be possible on a II-GS. And this does last. If I reboot the computer, notice it's still there. It does not save it into the card though. So if I power cycle the computer, that will go away, but it does last across reboots. When you're using this card on an actual Apple II-GS, then the control panel color settings will be output on the VGA card. That is actually replicated. But this mode just allows you to do that even on non-Apple II machines if you want to have some of that fancy border color stuff on your regular Apple IIe or II Plus, for instance. He added another mode here, which is Commodore 64-like colors, and obviously this is just completely silly. It just, well, it just does that. Now, any of these modes, except for I think the II-GS color modes, also change this into monochrome mode, which means when we boot up into software like Music Construction Set, then we're not gonna get any of that color artifacting anymore. And in fact, well, there you go. It's gonna look like C64 colors, which are kind of silly. I mean, there's a pointless mode here, but you know, it's cute nonetheless. Back in my little basic program here, you can see that there's green, amber, inverse modes of those, plus inverse of the entire regular black and white. And if we just go to 0, it will basically, oh, it put us back in II-GS mode. Didn't mean to do that. Let's just go back in the program here and let's change it to 128. And there we go. Now we are in normal monochrome mode. Now, if I boot up into the diagnostics, there it is. You can actually see the lines that make up the Apple II color being rendered perfectly. So this is a great mode if you're running an app, just like Music Construction Set or anything else that say uses text over a graphical screen and you don't want to look at all that color fringing. This is a great way to do it. As I mentioned, these features will be added into the config utility, so you won't have to use this little basic program, which incidentally, let's go take a look at the basic program. I hadn't done any programming in AppleSoft Basic in a very long time, and I was a little surprised if we break out of this. What I was surprised about was the lack of bitwise operations and or things like that that you can do on Commodore Basic, but you can't do on the Apple, and that just makes things a little harder to do. So what we're doing here on line 5 is it sets a base memory address, and that's basically if this card were located in this theoretical slot 0, that's the address where the card would be. And then we ask the user in line 10 what slot you're in, and then later when I go to poke the register value, which is there on line 1000, notice there it's the base plus the slot times 16. Oops, I unpaused it accidentally. The slot times 16 plus 1, that's the register for controlling the color mode. And this can really show the flexibility of a card like this because it's entirely software based. Putting new firmware on the Raspberry Pi Pico completely can change the functionality and the capabilities of this card because it's the Pico that is talking to the Apple II bus, and therefore where these register locations are, well, they could be changed to anything. We could add new features, new registers. He just gave me new software. I loaded it onto the card. It takes 2 seconds to load it on the card. If we take the card out of the system, all you have to do is plug a micro USB cable into the Pi Pico here and do that while holding down this button that powers up this card in sort of a programming mode. The Pi Pico just shows up as a drive letter on your computer. You just drop the firmware file into there and it instantly reboots and it's done. You don't need any special software or anything special to plug into this. It's just a regular file you copy on with a regular USB cable. Super, super cool. Earlier in the video, I mentioned that David had been working on firmware for this card that supported AppleII-VGA's new graphics modes, and here are some pictures he took off his VGA monitor running such software. So there's Thexter, here's the title screen from Out of This World, and here's his AppleII-GS booting into GSOS with the AppleII-VGA card displaying video. He did mention he's currently working through some issues on the high-res mode with some corruption and other small problems, but the low-res modes are working, although like I said, I don't have this firmware, so I can't test it yet. This may be a little off topic, but I want to touch upon the performance of this PCPI Applicard versus this regular Microsoft soft card clone. This is the Applied Engineering one, but this of course is the card that this VGA card could replicate. And this thing really does offer some pretty good performance for running basic programs, well, CP/M programs, but also even just basic programs on your Apple II, giving it a nice speed boost. I found this basic program online and I figured it might be good for some comparative benchmarks. What it does is it generates a fractal image, but it's doing it with characters. So all you need to have is a character display 80 columns wide, and then this is going to work. And it's written in very simple BASIC, meaning that any floating point BASIC will have no problem running this particular program, even stuff all the way back into the 70s. I typed in and ran this program on a bunch of computers, and I also asked some friends to run it on their computers so we could have a little bit of a selection of how fast this program runs on various machines. So on the stock Apple IIe, here it is. It takes 489 seconds to run this exact program. And on a 2GS in slow speed, it's exactly the same. Here's that same basic program run on this Z80 card right here. And it took 557 seconds, which, well, yeah, quite a bit slower than even on the stock 1 megahertz Apple II. And considering this runs at 4 megahertz, that's not so great. Right here on lines 9 and 10 is the performance of the PCPI Applicard running this exact same program. It takes 214 seconds on the real Applicard, and it's actually slightly faster on the VGA card emulating the Applicard. And probably because the timings is software controlled because it's running on that Raspberry Pi Pico, so I guess you get a little bit of better performance. But 214 or 211 seconds, more than twice as fast as running it on the stock Apple II. But you may be wondering, why does a 6 megahertz Z80 not run, well, 6 times faster than a 1 megahertz 6502? Well, I'm not going to get into it too much because that's a discussion for another video. But the 6502 and actually the 6800 and 6809, all of those 6 XXX processors that Motorola originated and then MOS made the 6502, they're very efficient compared to the Intel 8080 and also the Z80, which is really very much based on the 8080. Anyhow, there are some other results on here I just want to touch upon. There is a Microsoft Soft Card 2, which is a much faster version of it that has its own onboard memory, just like the Applecard here. And a friend of mine has one of those and it ran in 202 seconds. So even though it's the same 6 megahertz, it ran a little bit faster. You can see here the AppleII-GS running at 2.8 megahertz runs it even faster at 181 seconds. So that kind of shows the efficiency of that 65C816 processor, which I'm assuming if you had a 6502 running at 2.8 megahertz, it would also run equivalently fast. So it's kind of blowing the doors off of a 6 megahertz Z80. Although, keep in mind, we're talking about different basic interpreters, and there can be a lot of performance differences between one basic interpreter to another. So some of these performance differences are that. There's the GG Labs GZ80S. It's 20 megahertz Z80 and it runs it in 81 seconds. And I'm pretty sure that that thing is actually a clone of the Applecard as well. So it has its own memory on there. So it has that performance boost versus the regular Microsoft soft card. So if you really want the ultimate in Z80 performance on your Apple II, you gotta get that GG Labs card. But it's pretty expensive and it's not like it's a value add where it's just like built into this VGA card, which is of course extra cool. Anyhow, that was quite the tangent. Let's jump over to GitHub and take a look at the repo for this project. Here's the GitHub repo. I'll stick a link to it in the description below. The Gerbers, the PCB files are available right here, along with the documentation, all the utilities, the firmware, all that stuff. And David is very responsive to questions. And if you want to ask for new features or add new features yourself, feel free and go ahead. That is the beauty of open source hardware and software. David has a website for this project as well if you want to see more information about it. Here it is. Here's the current version. I think the one I have has the wireless module on it. It currently doesn't do anything, but I think there might be plans to add some kind of wireless support to this for the Apple II, but it looks like it can work with both types of Picos with or without wireless. And looking through the sample images on his website, look at this picture right here. This is in double high res mode, and notice that terrible color fringing. This is the Apple II desktop mode. Well, putting the card into monochrome mode would make that look pixel perfect. I don't happen to have a copy of Apple II desktop on my floppy EMU, so I can't show this off right now, but I guarantee you switching the card to monochrome mode will solve this particular issue, which is one of the reasons why I asked David to add that mode to the firmware. And if you'd like to get one of these and you don't feel like having the PCBs manufactured and you hand soldering those chips on there yourself, David does have a Tindie store, which here it is. There it is, fully assembled. It's out of stock right now, but it is $90. If you feel that $90 is too expensive for something like this, well, feel free to make it yourself using the PCB files. That again is the benefit of open source projects. So there we have it. That is the V2 analog card, and I think this thing is freaking awesome. I love open source, and when stuff like this exists and it works really well and actually has that fully functional support for the Applecard, that just makes it so much better. Open source has the ability to democratize this type of hardware. You don't have one person gatekeeping access to this device. You don't have to wait for that thing to come back in stock to get one of these. You can make one yourself, and that is what is so cool. And this project works really well, and this is absolutely a card that I'm gonna have floating around for use in my Apple IIs, at least the ones with cards, when I do video capture and stuff like that, because as I mentioned before, I don't even have any other VGA output device right now for the Apple II, and honestly, I don't really need one because I have this. So great work, David, on making such a cool project, and thank you very much for sending this in and letting me collaborate with you on adding features and making fixes to this thing. It's been a really fun project. I'll put links in the description to all the stuff that I've shown so far, so if you want to look at the source code or the Gerber files or make one yourself or buy one or talk to David, you can all do that in those links. So if you like this video, thumbs up. If you didn't, you know what to do. Hit that subscribe button. Thanks to my patrons. Names are scrolling up the side of the screen. I think the side over here. I'm always get confused. Yes, it's that side, I think. Those patrons get early access to videos. If you want to become a patron, you can do so in the link in the description below. And I think that's gonna be it. Yeah, put your comments down below. So stay healthy, stay safe, and I will see you next time. Bye.